Ashwin Kaur, and this is my presentation of SIT 5 Week 8.3 task, the smartphone accelerometer and the webcam collection task. So this is my Python script that I have written for the data to be present on the cloud. This process will collect the data and write it to CSV file every 10 seconds. This link I used OpenCV to capture a webcam photo. Both the data file and the image are saved with the same timestamp and the activity ID in the file name. So let's start by running this file. Okay, let's go to this local host. And again this one for the webcam. So this is me right here in the library, and these are my values. So it is moving a bit, like it is showing some movements because I am holding the phone in my hand, and if I just place the phone on a surface that isn't moving, then now as we can see that the lines are now straight and there is no movement. The graph is now straight, and this shows that there is no activity and no movement. Now, if I just start to move my hand a bit in slow waves, and it's showing vibrations and spikes. And if I just start to shake the phone rapidly, then it will show hard spikes in the data, in the graph. Yes, we all can see that it is now showing high spikes, and since now I am holding the phone, it is now slowing down and the peaks are gone. Okay, so moving back to our code, the next step was to make the annotation.csv, where each row includes the file name and the activity label. So let me show you that. So this is my annotation file. Okay, let's just stop this right here. This is my annotation file. Well, I have collected the data for 30 minutes, and then I made this annotation.csv file. I matched the photo with the corresponding graph pattern to decide what activity was happening. If the photo wasn't clear, I relied on the accelerometer plot to distinguish between the calm, moderate, or rapid movement. So this is my annotation.csv, and this is my code that helped me analyze. This is the code with which I analyze the ambiguous moments in the data. Like in this CSV, there was no activity. It had almost flat lines and only minor fluctuations. And this indicated minimal moment. And then in this CSV, waving was moderate with rhythmic oscillations and often in one axis, pausing on a shaking file. And then these were the difficult cases, as in these cases I was actually moving, but the photograph showed that it was shaking. It showed that the phone was shaking, but in actual I was just waving the phone. So this was an Autodesk waving, but with high resembling shaking. Data analysis helped resolve this ambiguity. Optionally, I'll show you my graphs, my plots for these cases. Like this is the graph for the first case where it showed no moment or minimal moment, and this is a random case. And then this is the difficult case where it showed showed like it was shaking, but in actual it was just moving. It was just waving. And then I'll run the code again. Okay, just a moment. let it update for a moment. And as we can see that I'm going to show that the photo will update in 10 seconds. See, yeah, that's me right there. And the data will update every 5 seconds. And it will be shown in this. Okay, so this is the PNG and CSV files that are being saved with this data being collected. And that's it for my video. I have added the GitHub repository link in my file. And thank you for watching. This was very insightful task that helped me understand how to collect, label, and analyze sensor data using Python and Arduino IoT Cloud. So thank you for watching.